There's often some confusion about the idea of probability of at least one thing happening, or at least something happening once. So we've got this idea of three dice, and we want to find the probability of rolling these three dice, so setting them into action, rolling them, and getting at least 1 6. So here's where it's very possible to make a mistake, and a lot of students will make a mistake here, and it's a very common one. And they'll say this: well, if I want to get at least 1 6, there's 3 die, and I'm going to choose 1 6. So there's 3 ways in which I can choose 1 6. And the ways that I would get that one, to get that 1 6, there's just one way. And that sort of ensures that I get a 6. So that's going to be getting a 6 here, or maybe it happens here or here. So there's 3 ways that I can choose 1 6. And then I'm going to multiply that by, well, here's where the mistake is. People say, well, as long as I get this 1 6 here, this is ensuring 1 6. As long as I get a 1 6, then, and this is where the mistake happens, so I'm going to say mistake. The mistake is to say, okay, as long as I have 1 6, then I could just say, well, anything could happen on the remaining die. 6 squared. And then I'm going to divide that by how many possible outcomes there are rolling a die, which we know is just 6 cubed, because there are 6 options for each die. So 6 times 6 times 6, or 6 cubed. Well, this simplifies down to, let's see, I think just 3 over 6, so 1/2. But that's not right. And let's try to figure out why that's not right. It might be helpful for us to think about a coin. So we could have heads or tails. And let's make this even simpler, and let's think about just, we're flipping 2 coins. And I want to find the probability of at least 1 head. So using this incorrect logic again, I would say there are 2 flips and I'm choosing 1. And then on the next, and there's 1 way that I get ahead. And then on the next flip, I don't care what I get, so there are 2 options. And I would divide that by, well, there are 2 options on the first coin and 2 options on the next coin, which says, 2 squared. All right, well, if we were to simplify this, what we get is 2 factorial over 1 factorial times 1 factorial times 2 over 2 squared, and this simplifies to 1, which means that 100% of the time I'm saying I would get at least 1 head. Well, we know that's not right. We know that's not right because we could either go head head, head tail, tail head, tail tail. So we know the probability should be 3/4. So where are we breaking down? We're breaking down in this statement and then thinking that we could put a 2 there. Why? Well, let me see if I can explain this. With this idea of getting either heads or tails, and the probability of getting at least 1 head, if we say, okay, there are 2 coins, and I'm going to choose 1 head, and then there's 1 way for that to get that head, so I multiply that by 1. Well, this statement is saying, okay, how many ways of those 2 heads can I just get 1 head? This is saying I want just 1 head in 2 coins. Again, this statement is saying I want 1 head in 2 coins. But now I'm kind of going against that logic and saying, no, you know what, I can have 2 heads. So this 2 choose 1 means that I'm looking for how many ways I can just get 1 head from the 2. So to then add this additional head, it's not working. It goes against this. To say I could get another head is contradicting that statement. Because if I'm saying I could get another head, what we really should be looking at is 2 choose 2. So this method doesn't work. What we need to do is honor the fact that that if I'm saying, the probability of at least one head, when I'm saying there are 2 ways that I can choose one head, then the next one is a tail, and there's only one way I can get that tail. The way that I say, oh, there could be other options, is to add these up. The other option is that there are 2 coins to choose from, and I'm getting 2 heads. And in that case, there are no more coins to flip, so I'm done. And then I'll divide this by 2 squared. And this gets me the 3/4 outcome that I would expect. Now with the at least one heads, again, the easiest way to think of this is just to say the probability of at least one head is 1 minus the probability of no heads. So for this particular one with these 2 coins, head and tail, we're saying 1 minus, well, how many ways could I get no heads? That means 2 coins choosing 2 tails. That's all of my options over 2 options per flip. And this simplifies, of course, to 1 minus 1/4, which is 3/4. I hope this makes a little bit more sense.